Good day, my friends. Unit 4, Analytical Trigonometry. Here we go. Last video we talked about the fundamental identities. Here they all are. Hopefully you wrote them down somewhere, or heck, feel free to even print this out. This is all of them right here. This is awesome. Now what we want to do in the next couple videos is use them. And there's several different things we could do with them. And this video is going to be quite simple. Actually, I think you're going to enjoy it, called Evaluating Trig Values. So what we're going to do is we're going to work on finding trig values. There's 6 trig values: sine, cosine, tangent, cosecant, secant, cotangent. We want to be able to find them using the identities. So let's just get right down to it. All right, so we want to use the information given below, and the identities, of course, to find all 6 trigonomic values for theta. Now, basically, I'm going to give you one of the trig values. As you see here, I'm giving you cotangent. Now, you actually should remember we've done problems like this before. For example, I've taught you the XYR method. So if you know cotangent, you automatically know x is radical 5, and you know that y is 7. And then, well, then you got to figure out, well, which one's negative? Is the x negative? Is the y negative? How do I know? Well, that is why it's so important that you know what quadrant you're in. And they're directly telling me that angle theta is between pi over 2 and pi, which is in quadrant 2. So in quadrant 2, x's are negative, y's are positive, so that automatically tells me the x is negative. And then, of course, you have to find r. Once you find r, you can literally find every one of the trig functions. But we're not going to do it that way. Another way I taught you is to draw a picture of angle theta. Even though I don't know what theta is, I can draw a picture of it. And I know based on that relationship, the adjacent side is radical 5, and the hypotenuse is 7. And now I just got to find that missing side of the triangle. And then again, once I have all 3 sides of the triangle, I can find all 6 trig values. But we're not going to do it that way. We want to solve this problem using the identities. And I actually think it's easier. You may not, but it's too bad the directions say to use the identities. Now, the work can get a little bit messy, but it's actually all very easy work. It's just algebra, which I know some of you guys are really bad at. So bear with me, and you're just going to have to work on it. All right, so first off, if you know cotangent, you automatically know the reciprocal tangent. And I'm using the reciprocal identity without even having to write it down, because I know that cotangent and tangent are nothing more than reciprocals of each other. And when you have a reciprocal, you keep your sign, so it's still negative. And all I'm going to do is reverse that and write 7 over radical 5, and voila, I am done. But of course, most people don't like leaving the square root in the denominator. So I'm going to multiply top and bottom by the square root of 5. And I get negative 7 radical 5 over 5. All right, so far I was given cotangent, and I just found tangent. So I got 2 down, 4 to go. Sometimes, some people like to make little tallies. So there's the 6 of them, and we got 2 down, 4 to go. Okay, you don't have to do that, obviously. Just joking. All right, so which can I find next? Well, first I want to talk about what you cannot do. I can't tell you how many students used the quotient identities improperly. They say, well, wait a minute, look, it says tangent is sine over cosine. So if you just found tangent is negative 7 radical 5 over 5, well, I guess sine is negative 7 radical 5, and I guess cosine is 5. That's not true. Or some people will also use cotangent. They say, well, listen, cotangent is cosine over sine. So if cotangent is radical 5 over 7, I guess cosine equals negative radical 5, and sine of theta equals 7. Wrong. It's a misuse of those identities, right? It's not true. What's happening, remember, is there's always trig functions are ratios. And when you divide 2 ratios, something is going to reduce or cancel out. And when you find cotangent and tangent, which are ratios, right? Y divided by x, or better terms, if your radius is not 1, it's y over r divided by x over r. So those r's cancel out. So what you see is y over x, or x over y for cotangent, but it means that there's something else there that we're not seeing. So please don't make that mistake. And the other thing is, at the end of the day, remember this: sine and cosine can never be more than 1 or less than negative 1. So there's no way sine can be 7. It's just not possible. All right, so let's understand that first. Now, so how am I going to find the other 4 trig identities? Well, the good news is, if you think about it, as long as I find sine, I'm good to go, or cosecant, right? I just need one of them. Because once I know one of them, then I can just go back to the reciprocal identity, because sine and cosecant are reciprocals of each other, And again, once you know one, you really know the other. And same thing is true for cosine. So if I find cosine or I find secant, once I know one of them, all I got to do is flip it over, find the reciprocal to get the other one. So it's not like I got a ton of work ahead of me because finding reciprocals is quite easy. All right, so what am I going to do? Well, I'm actually going to use the Pythagorean identities right here with the yellow stars. Because what I need to do is I need to find a way to relate these. I can't use the reciprocal identities. In fact, I already used them to find cotangent and tangent because they're the reciprocals of each other. But I can't use any of these because I can't find cosecant without knowing secant. Can't find secant without knowing cosine. And I don't know those. Same thing with cosecant and sine. And again, I just talked to you about how you can't use these because it's not going to work out because, again, something's reducing there. We just can't see it. So I'm actually going to go ahead and use these Pythagorean identities. And I'm going to go ahead and start using this one right here. Or I could use this one right here. You can actually use either one of them. Why? Because I know tangent. I know cotangent. And in an equality or in an equation, if you know one thing, you can easily solve to find the other. So since I was given cotangent, let's go ahead and use 1 plus cotangent squared equals cosecant squared. And let me show you how this works. 1 plus cotangent squared equals cosecant squared. Now, first off, what I want to explain to you real quick that I'm going to do is I'm going to find cosecant. By what I'm about to do, I'm going to find cosecant. Once I know cosecant, I can just flip it over to find sine. So I'm going to essentially knock down 2 birds with 1 stone here. All right, so 1 plus, now again, it says cotangent squared, but I know what cotangent is. So I'm going to replace cotangent with negative radical 5 over 7. Notice the square is still there. It's cotangent, pause, squared. I'm replacing the cotangent with what it is equal to, negative radical 5 over 7. The square is still staying there. And of course, this equals cosecant squared. So now I just got to do a little bit of squaring. That's going to be 5 over 49. Hope everybody understands that. Anytime you square a negative, you automatically get a positive. Square root of 5 squared is 5. Square root of 7 squared is 49. Easy, easy, easy math. Now I got to add. Well, I'm going to treat 1 as 49 over 49 to give myself a common denominator. 49 over 49 plus 5 over 49 is 54 over 49. So far, this is really simple math. Hope you agree with me. And now I don't really want to know what cosecant squared is. I want to know what cosecant is. So of course, I'm going to take a square root. Now be very careful with this. 54 is 9 times 6. So that 9 is going to come out as a 3. So 3 radical 6. Always reduce square roots. And 49 is a perfect square. That's just 7. So there is cosecant. How easy was that? Now hold on a second. I'm in quadrant 2. Don't forget about what quadrant you're in. It's something that kids just lose track of and they forget. I'm in quadrant 2, and in quadrant 2, y's are positive. And so its cosecant is by definition 1 over y, then it would need to remain positive. So cosecant is 3 radical 6 over 7. And it's going to stay positive because I'm in quadrant 2. Now, what about sine? Well, once you find cosecant, to find sine, all you got to do is flip it over, 7 over 3 radical 6. Honestly, I think you're okay with that answer, but most people are going to say, we don't like square roots and denominators. So when we go ahead and multiply by the square root of 6, we get 7 radical 6 over 18. Where am I getting 18 from? Radical 6 times radical 6 is 6 times the 3 makes the 18. So we get 7 radical 6 over 18 there for sine. All right, now I actually have several different things I could do to find cosine or secant. So going back to the identities, I could use this identity right here because, again, I know tangent, so I can replace the tangent and I can solve for secant. Once I know secant, I can reciprocate it to get cosine. Or I could actually now use this identity right here because I now know sine. And I can replace the sine, and then I could solve for cosine. So I got lots of options. It's really completely and honestly up to you. It all depends how you want to do the problem. I'm going to go ahead and I'll use the sine squared plus cosine squared equals 1, just to kind of show you something different to do here. All right, so I got sine squared of theta plus cosine squared of theta equals 1. But I'm going to replace the sine with, I find sine to be 7 radical 6 over 18. Don't forget the square. You're only replacing the sine. Cosine squared of theta equals 1. Now, squaring this is going to be a little bit tricky, so you might need a calculator. The denominator is pretty fairly easy. 18 squared is 324. Now on top, 7 squared is 49. Square root of 6 squared is just 6. So I have 49 times 6 in the numerator, which is 294. Plus cosine squared of theta equals 1. Now you should always try to reduce. I mean, come on, why would you not try to reduce fractions, especially when you get some big ugly ones that I don't want to deal with? So 294 divided by 324 does reduce. It reduces to 49 over 54. So I see 49 over 54 plus cosine squared of theta equals 1. Now this time I have to subtract that over. I'm going to subtract the 49 over 54 over. So I get cosine squared of theta equals. Now this time I'm treating 1 as 49 over 54 over 54, getting a common denominator, not a common numerator. That's not a thing. So 54 over 54 minus 49 over 54 is 5 over 54. Take the square root of each side, and cosine of theta equals the square root of 5 over, be careful, that denominator, 54 is 9 times 6. So the 9 comes out as a 3 radical 6. But hold on a minute. Don't forget what quadrant you're in. We're in quadrant 2. And remember, when you're in quadrant 2, cosines must be negative because x's are negative in quadrant 2. So I have to remember to tag on that negative. Can't tell you how many kids forget to do this. But of course, I don't like that square root in the denominator. So I'm going to multiply top and bottom by radical 6. And on top, I get negative radical 30. You are allowed to multiply square roots as long as they're both inside square roots. And the denominator, I get 18. Again, why? Because radical 6 times radical 6 is the 18. Or radical 6 times radical 6 is 6 times the 3 makes the 18. All right, then now to find secant, all I got to do is flip that over. So secant of theta equals negative 18 over radical 30. And once again, don't like that radical, so multiply top and bottom by radical 30. I get negative 18 radical 30 over 30. But don't stop yet, because the 18 to 30 are both reducible. They're both divisible by 6. So I get negative 3 radical 30, all divided by 5. So negative 3 radical 30, all divided by 5. So that problem, again, the using the identities honestly should be really, really easy. The hard part is really just dealing with square roots and reducing fractions and all that fun stuff. All right, let's do one more. And I actually made this last one easier because I want you to see when there's no square roots how simple the math can be. All right, this time secant is negative 5/3. So I instantly know cosine without doing any work. I'm just using the reciprocal identity in my head. I know that secant and cosine are reciprocals, so negative 3/5. How about that? Now, this is going, you'll say, why the heck do I care that tangent's greater than 0? That helps me understand what quadrant I'm in. So let's talk about this for a second. I already know that x is negative. How do I know that x is negative? Because by definition, cosine is x, secant's 1 over x, and secant and cosine are both negative. So x is negative. Now, where is x negative? X is negative over here in quadrants 2 or quadrant 3. But I'm also told that tangent is greater than 0, and tangent is y divided by x. Therefore, I have to be in quadrant 2, because in quadrant 3, both x's and y's are negative. And if you divide two negatives, you get a positive. Well, wait a minute. I'm sorry. I misread the inequality. I do a common mistake. I am in quadrant 3. I am in quadrant 3 because it says tangent is greater than 0. Since tangent is greater than 0, that means both x and y have to be negative. Hence, I'm in quadrant 3 because when you divide y and x, you get positive, which means tangent is greater than 0. Sorry, I misread the inequality. A silly mistake that a lot of you guys do. Sorry about that. All right, so what do I do next? Well, again, I can find sine. And again, once I find sine or cosecant, then I'm really set because I just need one of them and I just got to reciprocate to find the other. Same thing for tangent and cotangent. Once you find one, you really have found the other. So let's go ahead and find sine first. And I'm going to go ahead and use the Pythagorean identity. Cosine squared of theta plus sine squared of theta equals 1. All right, so how am I going to utilize this? Well, I'm going to replace cosine with negative 3/5 because that's what it is. Don't forget the square. You're only replacing the cosine. The square stays there. And negative 3/5 squared is 9 over 25, positive. And I'm going to subtract that over to the other side to solve for sine of squared. And be careful, I'm going to treat 1 as 25 over 25. So 25 over 25 minus 9 over 25 is 16 over 25. Take the square root, and this is what I was telling you earlier. This is where things work out so beautiful. That's going to be 4 over 5. No more square roots. 16 is perfect, 25 is perfect, so 4/5. But wait a minute, what quadrant I'm in? I'm in quadrant 3, so I've got to make sure y, like x, is negative. Therefore, sine is negative 4/5. And when I reciprocate it, I get negative 5/4 for cosecant. So easy, so easy. All right, now what I want to do real quick is, again, I'm going to go back to my identities. Now that I know secant, so I can actually use this identity right here to find tangent because I know secant. But I want to actually show you how this identity works to kind of make sure you understand what I was mentioning earlier with when this function works, when it doesn't work. So if you know tangent, that does not mean you know sine and cosine because of what I'm about to show you. So I'm actually going to use this to find tangent. I know tangent is sine over cosine. So what I'm going to do is I'm actually going to replace the sine and the cosine. So sine is negative 4/5. Cosine is negative 3/5. And this is tangent. But look what happens here. And this is why if you know tangent, that doesn't mean you know sine and cosine. So you got to be very careful. What happens is the numerator stays the same. Instead of dividing by a fraction, I'm going to multiply it by a reciprocal, negative 5/3. The 5's reduce, and I just get positive 4/3. Negative times a negative is positive. And remember, I knew tangent was positive anyway. So tangent is 4/3. But again, some kids will say, oh, if tangent is 4/3, that means sine is 4 and cosine is 3. No, it doesn't work that way. You can't use it in that direction because, again, there's always something hidden that got canceled out. In this case, it's the 5's. And then obviously cotangent is easy. It's just the reciprocal, 3/4. So it's so nice when you get perfect squares. We love perfect square problems because it just makes the math a lot easier. But sorry, sometimes you got to deal with imperfect square roots. You got to make sure you reduce them and fractions and all that fun stuff. Sorry, you got to deal with it. All right, so that's evaluating trig values. So being able to use the identities. Again, this is not brand new. We've already talked about doing this. We just use the XYR method or the triangle method. You are more than welcome to use those methods to check your work, but I need to see the work of the identities in terms of how you got your answers. All right, guys, that's it for this video. We'll see you in the next one when we start to tackle simplifying.